Okay, so the last type of energy we're going to take a look at now, and we'll take a look at a lot more if you come back and take AP Physics 2, is thermal energy. And as we talked about before, of course, this is energy that's lost due to friction. Oops. So this is lost due to the contact surfaces touching each other. So thermal energy, it's the sum of all the kinetic energy of the molecules. So when we talk about things like temperature, temperature is a measurement of kinetic energy, okay? And the best scale for this, of course, is the Kelvin scale. And you guys know this from chemistry class if you've taken it. 0 Kelvin, notice how it's not degrees Kelvin, it's Kelvin, represents no energy. So an object that's cold has very slow moving molecules. An object that's hot has very fast moving molecules. And that's all thermal energy is. So when we have friction, friction transfers some of the energy from the object to its environment by speeding up these molecules, and that's what happens to it. So here's a picture, for example, of a block being dragged across a surface, and you can see this trail here with this thermal camera because it is having this surface-to-surface contact, so that's heating up. The amount of energy that's lost due to friction, or the amount of energy that's converted into friction, is the force of kinetic friction times the distance. Notice, though, that this is essentially force times distance, which makes sense because all energy can be removed from the system by doing work, which is force times distance. Now, this makes it really easy for like flat surfaces, but when you have like either like a linear surface or like a curved surface, it's really hard to actually calculate this because the force of friction from unit 2 is the coefficient of friction times the normal force. So what's my normal force at this point compared to this point, right? It makes it really difficult. So we look at thermal energy in a whole or as a whole, and we won't spend too much time looking at it, but it is essentially just the force times the distance. So I'm going to do a demo in class where I have two spheres, and they're pretty massive. And then I'm going to hit them together, and I'm going to give them all this kinetic energy. I'm going to put a piece of paper in between them, and we'll take a look at what happens with those colliding spheres. One thing you can do yourself, it's stupid, but you can, if you rub a soft object, such as a blackboard eraser, on your desk for a little bit and pass your finger over it, it'll be hot. And the reason it's hot is because you're doing all this work to excite electrons, and then you're giving it thermal energy. So it's this combination of energy transferring and energy transforming to make that happen. So that's your quick little overview of the different types of energy. Next thing that we're going to look at is what do we do and how we do these energy transformations from one type to the other, and we'll get a little bit more quantifiable in the next section.